Recording. Right, so welcome everyone. Good afternoon or good morning, good day, wherever you happen to be in the world. Welcome to our weekly call. As you're hopefully all aware, today we're going to spend some time learning a bit more about Apple's recently announced private relay service, which I have erroneously called, I think, private replay, the joys of spell checkers. And in my head, at least, frame relay, just betraying overlaps with other areas. But as far as I'm aware, it's definitely officially called, is it iCloud plus private relay?
iCloud private relay.
iCloud private relay, fair enough.
Which is available as part of iCloud plus.
And as you may have inferred, Tommy has kindly agreed to answer questions. The plan for today is, and I'll put them up on the screen in a moment so you can actually follow them, because that might make it a bit easier. The list of questions of which I circulated the latter part of last week, we'll endeavour to work through those. I will confidently predict it won't be feasible to go through all of them today, even if we talk really, really quickly, just to sort of set expectations. And also, as most of you will be aware, because they put it in the email, Tommy will focus on the technical questions. So we'll no doubt skip over the odd question or two along the way, which are more, if I call them policy orientated, so non-technical perhaps might be a more accurate description. So Tommy, I guess you'll use your judgment and tell me when you think we're on one of those. So we'll skip over those for the moment. And in terms of our ability to take questions from the floor, as it were, I think, again, in the interest of time, happy to take questions of clarification, but I'd rather not take any other questions, because otherwise we'll probably only get through a half dozen or so of the questions that were submitted in advance. So if you could only raise your Zoom hand if you've got a clarification question, but otherwise I propose we'll just plow on through and see where we get to, which does remind me I should switch on auto transcription, which I think is now on. Yes, it is. And it will no doubt throw up some fascinating, if occasionally funny, interpretations of what we said, but it will hopefully aid those in noisy environments or who need a bit of help just to follow the flow of the discussion. So let me just quickly put on my screen the slide which I have prepared earlier, or slides, which I'm hoping you can all see.
Yep.
And all these slides contain, apart from this very first one, is exactly the same questions, because I cut and pasted them, that were in the PDF document. I've just sort of grouped them as best I can in the sections. So if you want to follow them on the PDF, you can. So I propose, let's start. So we go from the top with technical details first. So I hope we're on safe ground with these ones first, Tommy, at least.
Sure.
So as it says from the top, which protocols, particularly IETF protocols, will be used and how? For example, is mask going to be used?
Yeah. And so this is something we've detailed a bit in our WWDC talks, but we are indeed using mask, which is really just the connect and connect UDP methods with HTTP3 for the proxying of actual data. So essentially, this is a combination of using connect UDP as well as using oblivious DO. And so essentially, between those two, that covers everything we're doing. The one other case is that in situations where Quick is not available on a given network, we do fall back to connect over HTTP2. But that's only used when HTTP3 is not working.
Okay, makes sense. And how exactly is Odo used within private relay?
Yeah, so for fully proxied traffic, we don't use Odo at all currently in what's out in the current betas. So everything I'm going to talk about is just about what's in the current betas, because that's all we can guarantee in life. So that traffic goes connect UDP and then connect out the other side. For traffic that is not going to be fully proxied, that is instead just getting DNS protection, we talk to the same initial proxy that also does mask, but we just do a post request there of DNS traffic. So it's really kind of one or the other, that it's all behind one initial proxy node, but it will either get a connect or connect UDP request through that node, or it'll get a post of an Odo packet.
Okay. And then, given that Odo isn't finished in the ITF, as you'll be well aware, what's the plan to deal with any version differences?
So based on the last the deprive discussion, they decided not to adopt it. So we're actually doing that on the independent stream currently. And so actually the version that is like currently in the repo is the final is version 1. So we are using version 1. That's not to say that there can't be another version in the future. I think the direction to the next question is that, I mean, the reason people didn't want to adopt it is they're saying like, oh, this will probably just get merged into oblivious HTTP at some point. I think that is a little ways off still. So essentially, we will be using just the oblivious DO formation of this for the foreseeable future until at some point, if that gets overtaken by a version of oblivious HTTP that also provides the same functionality, then that may happen, but that's not, in the next year or two.
Yeah, because Odo is experimental.
Yeah, it's experimental, and given that at this point we're kind of coordinating with the various servers who can provide it, it's not a complete Wild West of having to interop with anyone.
Yeah. Okay, you covered off the next one, which is helpful. So moving on to question 5. What's the host name of the iCloud private relay proxy server?
Yeah, that is mask.icloud.com. There's also mask-h2.icloud.com as a fallback. And I can provide actually a link. Hold on. We have recently posted a public article that gives some of the details authoritatively on this. So I will try to pull that up and add that to the chat.
And for anyone that can't easily copy and paste from the chat for whatever reason, I'll pop that in with the notes post call.
Yep. So I've added this in, and that is to the question in the chat, mass.apple-dns.com. I think that's just the CNAME it goes to. So you could follow the CNAME chain. Like it's the top level thing we initially ask for is mass.icloud.com.
Yeah. Thank you. And are any other Apple services associated with that host name?
It is only the things that we're proxying for privacy reasons, which does include some system level features such as the mail privacy protection and the default Safari protection for third-party web trackers. But it is always the same functionality. It's not non-proxying use cases.
Yeah. Yeah, which I suspect was probably behind. That's what was behind the question. Will a single client device use a single private relay tunnel per network, or can it use multiple tunnels even through a single network? And if so, when are these set up and torn down?
Yeah, it will definitely use multiple, as you could easily tell if you look at packet traces, etc. The proxy connections are done generally within a process. It's not like a VPN. It's done more like a traditional proxy configuration, which the proxy happens within the networking stack of the application. So when we have mail traffic loading tracking pixels at the same time as Safari traffic, those run in separate connections because they are separate apps.
Yeah. Okay, and last one in this section, which applications other than Safari use private relay?
So I just mentioned mail.
Yeah.
But then beyond that, we are protecting any unencrypted HTTP traffic on the system. So it can be any app, as well as protecting DNS traffic for all apps. So all applications can use it for eligible traffic types.
Okay, so it's more by traffic type than it is by
Right.
name of app then.
Right, with the exception of Safari getting the full coverage as a name of app thing.
Yeah. Okay, that's all of those ones so far. So good. Let's move on to the second page. So moving on to Ingress and egress proxies. So we're on to question 9 if you follow this on your PDF document. So can you say which company or companies provide the hosting for Ingress proxies?
Yeah, I'm not going to comment officially on that. However, you can look at the published article which I provided, which contains the IP addresses that are being used for egress.
Okay.
Oh, Tommy, it's the Ingress. I think the answer is 1.
Oh, sorry. Oh, sorry. That. Thank you, Bill. For Ingress, right now it's being operated by, I mean, the code running on it is Apple code, but I'm not going to comment on who is hosting the actual hardware right now.
Okay. And then moving on to the egress proxies, and for the avoidance of doubt, all of the remainder of the questions on this page refer to egress, not ingress.
Thank you.
Is the plan to work with different egress proxy providers in different territories? So might it be a difference between, as it says on the page, between say Europe and the US? I'm not sure that, but just noticed a typo there, so apologies. Will there be multiple providers in some or all territories?
Providerships, yes. So starting at the end, there are certainly always going to be multiple providers for all regions. That's an important privacy and kind of non-centralization principle we want to have. We don't want everything going to one company, even though the egress proxy cannot see that much traffic. It's very important for the device to be able to choose to randomly spread it around. With regards to different countries and territories, the system can allow for having different providers in different regions, but I can't comment on specific plans of whether or not we would choose to have any region be different than others. Yeah.
And it's probably early days, in fairness. So the fact that there might be in the future might be perhaps which is helpful.
And Andreas has a comment. Yeah, I mean, it is a criteria that we always have multiple providers. Everywhere where we're running currently, we have multiple.
Yeah. Okay, so I think you've already said you won't name.
Yeah, I guess the one thing I can say is that, I mean, purely from a personal standpoint, I think the desire is that the list can be expandable, right? And can can certainly having this grow to be a larger ecosystem would be a valuable thing.
Yeah, and are there, which sort of, if I sort of blend in the other questions with question 12, are there published requirements for the egress proxy providers? So things such as transparency and privacy policies, audit requirements for those, etc.
Yeah, this is the type of thing that we don't have published yet, but as we draw near to kind of the non-beta release, there should be some documentation of.
Yeah, and I suppose we should keep reminding ourselves it was only announced last month, in fairness.
It is in beta.
Yeah, quite. So that's perfectly reasonable. How can you guarantee, or do you guarantee, that there will be no collusion between the ingress and egress proxies?
So, right, I mean, largely the separation of ingress and egress at a technical level is designed such that neither has the information to kind of track a full user's flow on their own, such that tracking user information would require collusion. The client is the one that selects the pair of ingress and egress. It knows the identity of kind of the company that's hosting ingress and egress. It can make sure that they're never the same. As far as proving that the companies themselves do not collude here, that is more kind of a policy and contractual thing. So again, details that can be published later, but
yeah, I suspect
we are certainly very dedicated to not having them collude.
Yeah. Is there, I think the question was more, is there anything in the code? Because I think that was one of the queries raised in the discussion around Oblivious generally. Is there any way you can technically check whether there's collusion between them or not?
Yeah, I mean, I think that's an interesting kind of philosophical area to discuss more of, like, how possible is that. I think there are a lot of technical decisions made such that the different entities never send information directly to each other. For example, like the ingress and the egress do not really have any connection between them. The client creates a quick connection to the ingress proxy, has a connect UDP connection to the egress proxy, but there is no channel on a per connection basis between the ingress and the egress. So any collusion would have to be completely out of band and not part of the system itself.
Okay, which will be pretty challenging to then prove technically within the system. Right. Yeah. Okay.
Right. It's hard to prove that someone didn't, like, pick up a phone.
Yeah, quite.
But they would require that level of thing.
Yeah. Okay. And then finally on this section, will Apple ever operate egress proxies?
No, we're not right now, but that's not something that I would rule out, and I imagine at some point, yes.
Okay. Thank you. Right, so we're on to the user experience. Is the user experience of accessing a network where the iCloud private relay proxy server hostname is blocked different if the user is connected to a cellular data network, Wi-Fi, or an Ethernet network? So does it vary between them in terms of the blocking?
It's the same experience, modulo, some minor text on the prompt that says your Wi-Fi network or your cellular network, or for a Wi-Fi network, we give the SSID. For an Ethernet connection, we give the name of your adapter. But really, that's it. It's the same across all of them.
Yeah. If the IP addresses associated with the iCloud private relay proxy server are blocked, are other Apple services impacted?
So for that, I mean, in some ways, yes, in that, you'd be ending up blocking DNS for anyone who has the feature enabled, but these proxy servers are not being shared with other services directly, which I think is what the question is getting at.
Yeah, that would be my
Yes.
interpretation. And out of interest, given that potentially DNS, for example, could be impacted, would that fail over to something else, or how would that work?
So what we were saying, if people are trying to do this for kind of firewalling purposes, or to say, hey, this is a network where we need to actually monitor all activity, we are highly encouraging the blockage to happen at the DNS level rather than just dropping UDP packets, because it's much, much faster for us to kind of guarantee a good user experience around that.
Yeah.
And the idea is that the kind of the pop-up would come up, and then the user would choose to disable the privacy feature for that particular network. And if they choose not to, then they will change networks, or they will have no internet.
So it will fail closed. Would that be the right interpretation?
Yeah, that's right.
Yeah.
Well, or allow fail open with transparency and user choice. It's all about trying to make it more clear to the user when the network requires monitoring versus not.
Yeah, fair enough. So some service providers provide device agnostic opt-in security and parental control services using DNS and/or DPI. Is Apple taking any steps to prevent service providers from blocking access to the iCloud private relay proxy server for opt-in subscribers on their networks?
I mean, there's certainly no steps to prevent that. I mean, those networks, if they choose to do it, will cause a prompt to the user to get them to disable it per network. Again, that's about transparency there. We are certainly encouraging that certain models like this, whether they are MDM or a parental controls case, can use on-device content filtering APIs, which are quite powerful. We're encouraging that they can use that, because then these deployments can get both filtering and privacy, and potentially filter more correctly, more completely on all networks. But we certainly recognize that there are going to be networks that kind of want to have control over that, and can't really stop that.
Yeah. In a similar vein, I guess, could network operators opt out of private relay for individual connections, for example, to respect customer requirements for parental controls?
By individual connections, do we mean individual devices, or?
I took that to mean probably individual users.
Yeah, that I mean, certainly, if a network knows that one subscriber has some extra parental controls and another one doesn't, they can choose to block DNS differently.
Yeah. Okay. And so, notwithstanding that, what user dialogue? So, imagining, for example, that I enable private relay, will there be any user dialogue to explain to me that there may be an adverse impact on things like parental controls or malware filtering?
We don't have anything like that in the current beta. Can't comment on whether or not there will be something like that in the future.
Okay. In the release version of where it says iOS 15, read that for all of the equivalent. It's just in the interest of time. So in the release version, will private relay be turned on by default?
So it's important to note that you need to sign in with an iCloud Plus subscription in order to even be able to use the full version of the feature, and it does have kind of user transparency about the feature being on, but for those who do subscribe and sign in, it is available to them by default.
Yeah. And are you able to say at this stage, is it going to be iOS 15 or iOS 15.1, or based on current plans? So is it like
it is available as part of the current beta of iOS 15. So
okay. Accepting it's a beta, so stuff might change conceivably, I guess, but yeah, okay. Yeah. So if for some reason I've enabled private relay normally and it's all working correctly, then it stops for some reason. I think you already answered this, but just for completeness, what will the user experience be?
If we detect a service outage, then we will send a notification to the user that indicates that the service is down and temporarily unavailable, and that will be turned back on at a later time automatically. So it will kind of fail open if there is a problem with the service itself, but with transparency.
Yeah. And could a user such as an enterprise be able to run their own Ingress proxy, or are they limited to using Apple or whichever other?
Yeah, in the current version that is not flexible. However, if people would like to talk about that for the future, that's an interesting topic to talk about.
Okay. Thank you. Right, let me move on to the next slide. So this is still user experience because the text got far too small to read on one slide. So for Apple users, will enterprise MDM solutions have the ability to control Apple private relay behavior on devices that they manage? So either via third-party MDM, which will rely on Apple APIs, or through Apple Business Manager?
Yes, but limited to supervised devices, which is the case of an enterprise-owned device that they can turn off various iCloud features holistically. If it's just like a BYOD device, then certainly an enterprise network can block private relay on its own, but that would be up to the user to kind of acknowledge.
Yeah. Yep, fair enough. So, and if the user or corporate MDM has specified a DOS server in iOS via a profile using the functionality that was added in 14.x, will that DOS server still be used if Apple Private Relay is available? So I guess
yes, we use that DOS server instead of the Oblivious DOS.
Yeah. And this is a similar question, but with a different example. If you have an existing DNS provider installed and then you turn on Apple Private Relay, which gets precedence for your Safari DNS queries?
This is something that we were talking to the Next DNS folks about. I believe in the current beta, it didn't use it at all, and I believe that should be fixed at some point in the future.
So is the intent that if you've got a specified DNS provider and then you turn on Private Relay, that
it's used, yeah.
Which is used, the existing DNS provider?
The one that the user installed.
Right, yeah. And what about non-iCloud Plus users? What will they experience? So will they also use Odo, or is this just not available as a feature for them?
Yeah, they don't get any built-in DNS protection.
Yeah, that's pretty clear. And I'll ask this one. I suspect I know what the answer might be. Is there any plan to roll this out beyond iCloud Plus users? So it becomes a free feature.
I cannot comment on the future. No idea.
Yeah, kind of anticipated that. Okay, and another sort of, I think the last of the user experience questions. So many websites require an increased level of authentication if the client's connected from either an address that isn't one operated by your usual ISP, or one that perhaps is shared by many others and has seen malicious activity in the past. Are you measuring the extent to which Private Relay drives this website response?
We're definitely tracking that and being aware of that. Yeah, and I think this is an interesting area, talking from a standards perspective, working on IETF, for there to be more ubiquitous and better standards around authenticating users without too much impedance. There's work going on in Privacy Pass and other places that I think is very interesting and should prove to be more useful than relying on IP addresses going forward.
Yeah. Now I can see Andreas has raised his hand. I think there might be.
Is that from before?
Yeah. His hand's gone down, so it must have been. Bill's put a question against question, supplementary to questions 23 and 24, linked to adaptive DNS.
I was just saying that we've got the example in Android and a lot of work in adaptive DNS to separate the encrypted transport layer from the provider so that you can switch encryption methods without switching providers. And so, one would hope that relative to questions 23 and 24, Apple's eventual solution would allow users to specify that they wanted encryption or relay or whatever without having to separately repick their DNS operator. But
yeah, exactly. And I think right where it says DO there, that could be any transport.
Yeah, I'm not sure if it's really answers the point, because what we did, Tommy, is we did, for example, set the next DNS, or also our Vodafone DOH server, as part of the device DNS profile as the preferred DNS service, right? And our expectation would be that all the DNS traffic we see from that iPhone would then go to that specific, let's say, next DNS or Vodafone DOH service. But we can see this only happens if we, in addition to this setting of a DOH in the iOS, we would also block the iCloud masking URL. Only then we see the entire DOH traffic going to the Vodafone DOH.
I think this is something we should take offline. I think there were a couple bugs in the initial betas around this.
Yeah, happy to take it offline, no problem.
Yeah. That's not the intent of the paper.
I actually spoke to the guys at NextDNS about this, and they told me that they'd spoken to Apple, and it was a fault in the current beta and will be fixed in the next beta.
Yeah, we can park it till the next beta release and then see if it happens still, and then we can have a talk about it.
Yeah.
Okay. All right. So I think we've covered the things in the chat. Was that your question linked to this, Andreas, or was there something else, clarification point you wanted?
No, all good from my side now.
Okay, thank you. Slightly smaller type because these are slightly longer questions. Again, as you can see, all sort of network related ones here. So running through them. Firstly, quick encapsulation adds transmission overhead, which is probably not a problem on the downlink mast to device, but could impact uplink device to mast, as that is typically scaled for significantly less capacity than the downlink. And additionally, encapsulation may exacerbate performance issued under weaker signal conditions with multiple retransmission attempts, etc. So you may end up with basically sort of filling the capacity and constantly backing off and just getting in a muddle. That's a statement rather than a question. Is that something that you've thought about? I think would probably be the implied question there, Tommy.
I don't believe we're actually adding that much overhead. So when we are doing connect UDP through the Ingress proxy, we are doing our quick aware connect UDP, which means that it is able to, after the initial handshake, forward packets directly from the client to the egress proxy. And then the egress proxy is doing a connect method generally. So it's talking TCP to the other end. And so it's a transport, like you have a transport from the client to the egress proxy, and the egress proxy talks to the server. So we're not fully encapsulating full IP packets here. You're really just comparing a quick stream to a TCP stream, and at that point, the headers required on a given quick stream are quite small. So it's not, we're not encapsulating all the time.
Okay. Since I happen to remember the author of that particular question, I don't know, and I think Kevin's on the call. Does that answer the question, Kevin? Because I know you were thinking of a particular scenario here.
Thanks, Andrew, and hi, Tommy. Thanks for that. Yeah, so it was really just the radio air interface I was thinking about there. So if you're not adding bytes to the radio air interface, or it's more or less the same as we'd expect now, then that's not a problem.
Exactly. Yeah. That was very important for us to not have extra bytes being added here.
Nice one. Thank you.
Like maybe you just like one or two, but like it's very, very small.
Sure.
Yeah. Okay. Also with Quick, given it sits atop UTB, which is typically treated as a special case at operator firewalls.
Yep.
E.g., UE initiated UDP is granted a temporary pinhole in the firewall which closes after a timeout. TCP connections have a stateful mapping to the CGNet to match outbound to inbound connections, and on average there are 6 TCP connections per web domain. If these TCP connections are now encapsulated in Quick/UDP, there is likely to be an impact in scaling and configuration at the firewall/CGNet.
Here, certainly UDP does have different NAT interactions. I'd love to see going forward NATs be a bit more quick aware so they can handle it better. In the meantime, yes, we have to do more keep alives to keep NAT bindings open. However, Quick can also maintain itself across NAT rebindings through passive migration. As far as the scale at these, generally, if you're doing web browsing, there are very, very many connections that you're making. And as you're traveling between different tabs, it's opening up many dozens, if not hundreds of connections. Those are all just streams within a single Quick connection. So while yes, it is a UDP connection, there are far, far fewer 5 tuples being used by the device.
Thanks, Tommy. Yeah, this is Kevin again, because this was one of mine again. Yeah, I agree. I think this is not necessarily a problem. It's more of a consideration for mobile networks, just to take a look at the firewall configurations and make sure it's set up and can handle it.
Right. And I do think, beyond this feature, the fact that HTTP3 is growing in deployment and is Quick itself is standardized now, it'd be good to have some awareness and potentially tuning of NATs for those.
Yeah, agree.
And before I go on to the next question, Zaid has raised his hand, presumably again, clarification point on this one.
Yeah, actually, maybe a follow-up since performance was mentioned. The question is, are there or will there be any performance numbers published with regards to this particular protocol?
With regards to Quick or this particular deployment?
This particular product per se.
I can't comment on that right now. We haven't published anything yet.
Thanks.
Right. Thanks, Aid. Okay, about to move on, but Chris has raised his hand as well. So Chris,
yeah, just on this one. Yeah, I certainly think there'll be far fewer connections needing natting. Just wanted to ask, do you have a particular recommendation on the NAT timeout that would work well with private relay?
I mean, we're needing to handle timeouts of 30 seconds because that's a reality on UDP for a lot of places. But I would say, the closer it can get to the TCP timeouts, the better. And there are ways that NATs can, detect quick resets and other things like that. Okay, as long as it is feasible, I would say.
Thanks.
Great, thanks, Chris. Right, we're up to question 30. Also Quick related. Quick involves padding for privacy reasons. However, mobile networks typically have standard MTUs of around 1500 bytes and maximum segment sizes to avoid fragmentation. If there is a Quick encapsulation that exceeds the MTU, then there could be a fragmentation causing configuration problems and therefore a poor user experience.
So I think this gets kind of back to 28 of not wanting to have extra encapsulation, and certainly fragmentation would be a very, very bad outcome here. And we are, Quick packets themselves have a must in the RFC to say you must set the don't fragment bit, you must not do fragmentation upon sending. Of course, the network can always add its own fragmentation in there, but yeah, everything should fit within 1500 bytes for sure.
Okay, and then last of this little block, mobile has historically performed poorly with classic TCP algorithms, which wrongly infer packet loss for packets where an ACK has not been received by the sender, but which are undergoing radio layer retransmissions. This disconnect between volatile radio conditions and end-to-end congestion control results in the inefficient sawtooth pattern of sender rate over time. Recent algorithms such as BBRV2 attempt to monitor jitter, variance in latency for finer tuning. What algorithms has Apple in mind for quick encapsulation?
Yeah, and this I think is a more general question than just for us. We are working with different partners and they all have different implementations, then they have their own congestion control. I think this is going to be an interesting area, and the conversation should probably move to ICCRG, and there are better people than I who can comment on that.
Okay, so note to the mobile network people to do exactly that. Thank you. Okay, and not a quick question, but still a network question. Propagation latency is typically the biggest contributor to end-to-end latency, notwithstanding poor signal conditions. If the ingress proxy and egress proxy are geographically remote to each other, this would or could increase propagation latency significantly on a round trip. What's the strategy for good matchmaking between ingress and egress to minimize that? Yeah,
and this is one of the reasons that this is a fairly controlled and limited selection of ingress and egress proxies. I mean, I can't go into all the details, but yes, there's usually a very strong affinity between which ingress and egress locations we would have to make sure that there is not any of the extra latency there. It should be very, very, very small.
Yeah. Thank you. So I'll move on to the Next set on geolocation. So easy one first. Is the intent that the ingress and egress proxies will always be in the same country as the user? And are there any circumstances when this will not be true?
I guess, as we have described in our WWDC content, the IP address used by the egress proxy will always map to the same country that the user is in. That does not necessarily mean that all of the hardware is physically located in that country, but it has the IP addresses allocated to that country.
Yeah, which is probably a better question to have asked, thinking about it.
Right.
Yeah. And sort of linked to that, sort of noting the potential disruption for serving content efficiently. I think we talked, starting to think about CDNs and such like. Is there a maximum distance from the user to the egress proxy?
I don't think that's just quite makes sense. I mean, in terms of physical distance, really what matters is kind of the network latency and the efficiency between the client and that egress proxy, how the network is set up. So, certainly we want to minimize the latency between the client and an egress proxy. Of course, we cannot control the latency between the user and their access network. So I think there's just a goal to have everything minimized. Yeah, exactly. Bill is saying, yeah, we have no control. It's just up to the user's ISP. So yeah, we want it to be minimized, but that's as best as we can do. Yeah,
I suspect the question was probably driven by wanting to minimize off-net traffic by an ISP, but I'll let any ISP's representatives comment on that should they wish to, preferably in the chat. Okay, for DNS traffic, how will the resolver selection be made? Will resolvers implement any national legislative or regulatory requirements in the country where the user is located? Will malicious content be blocked or CSAM? And how will network-based parental control settings be preserved?
Yeah, I'm not going to comment on this right now.
Okay. I might guess the next one, but I'll ask it anyway. Will geo-filtering requirements for copyright protection purposes be respected?
I mean, for this, for like media access and copyright protections, again, we are making sure that the IP address selected by the egress proxy corresponds to the user's country. So any web servers that are filtering content based on what country user is coming from should have no impact.
Yeah, good point. Okay. Impact assessments is the next section. So what impact assessments has Apple undertaken on network operations and network performance, including DNS and SNI-based content filtering, zero rating of traffic, cybersecurity, content caching, and peering routes? And if none, are these planned, and will the results be published?
Yeah, I don't think I'm going to comment on this one.
And then more generally, has Apple done an impact assessment on how this will affect the existing internet architecture, including security, safety, etc., as before? If not, is this planned, and will the results be published?
I'm going to skip on this one too, thank you.
And then finally in this section, what other engagement has taken place concerning the deployment of the service? Have ISPs been consulted on this? And if not, is there a plan to engage with them and indeed the wider stakeholder community ahead of rollout to identify any other potential concerns or unintended consequences?
Yeah, I'm not going to comment more on this one. I mean, we're talking to people now, so low stakeholder community.
Yeah. yeah, to be fair, it doesn't ask you which ones. It just says, is stakeholder engagement happening? I think is the gist of that. So yes is the answer. Okay. Right. How has the decision been reached not to roll out the new functionality in certain countries? And was there any consultation with the governments, I guess, of those countries?
Can't comment on this.
And would it be reasonable to assume, Tommy, you might not wish to comment on which?
Nope.
So yeah, which ones?
Yeah, I don't think I'll comment on any of these.
Yeah.
I'm not a lawyer.
So will that apply also to the bottom two of compliance rather than?
Yep.
Yeah.
Yep.
Fine. Okay, that saved me reading them out loud just for you to say that, which is a bit tedious for everybody else. Fantastic. In that case, we've actually got to the end. Much to my surprise, I didn't think we get that far in so
well,
little time.
The end got a lot quicker.
Well, yes. Yeah. To be fair. Okay. Well, in that case, that's fantastic. Thank you for that. Which surprisingly gives us time if anyone has any supplementary questions, but obviously don't go asking ones a bit like the ones currently on the screen, because that would be a bit pointless. Having said that, I'll stop sharing. So does anyone want to jump in? So Peter, yeah, you got your hand raised. You want to off mute?
Hi, and thanks very much for your time, Tommy. This is it's been really interesting conversation. I was curious, and I apologize if this has been answered elsewhere. There's been a lot of different new information sources coming in. What are the sort of plans for HTTPS support? You know, installing a local certificate and proxying that side of things.
So sorry, can you clarify a bit more?
Are there any plans or thoughts about using the private relay for HTTPS traffic or SSL traffic?
For app traffic, because we are doing it for Safari traffic.
Yeah, for in general. For like,
you know, that's not part of this initial offering.
Yeah.
I think in general, like philosophically, like we are interested to see how it expands, but yeah, it's something that is going to be a future decision on that.
Okay. All right. Well, thanks. Yeah. Thanks again for your time.
Yeah, absolutely.
Thanks, Peter. Last chance for anyone else with any other questions. Obviously with the P's today. So Paul Breers, you want to come off mute?
Yeah, we talked earlier about like the DNS providers. Like I think NextDNS was mentioned as an alternative provider, and the discussion about the beta. But ones that are working via a VPN rather than as a DNS in there, will that carry on working because the VPN takes priority?
VPN does take priority for the names and the routes that it's associated with. So if you have a split tunnel VPN, it only gets, you have a split tunnel VPN and then private relay for everything else. But you can have VPNs that take all names for DNS if they want.
Okay, thank you.
Which, from memory, exactly follows the prioritization you did for Doe, I think, then, or the same approach. Yeah, helpfully. Right. I was about to say I haven't got any other questions, but Bill's raised his hand, so probably make this the last question, given we're hours nearly up, and I know you've got a hard stop, Tommy. So, Bill, do you want to come off mute?
This actually just follow on the last question, since that has historically been a very specific security problem at Apple. The VPN selected DNS server not always being respected in cases, for instance, of the captive proxy traversal. Is there new code here? Has this area been overhauled, or are we adding something onto the side and hoping that somebody else fixes the underlying problem?
So the VPN code itself, installs the policies onto the system to take precedence over private relay. Cases where traffic would not have gone through the VPN's resolver, that it doesn't affect that, right? So it's really just saying anytime you do go through the VPN's resolver, you won't go through private relay.
So you're saying essentially the VPN gets higher priority than private relay, but if something else takes higher priority than the VPN,
correct,
that hasn't been fixed.
Correct. And then that's something we can go into the details of. There are there are like things like our always on VPN solution for kind of like the supervised device government grade VPN, which does not have any exceptions for captive network traffic. So yes, I agree. It is a complex area.
Okay, thanks, Bill. Fantastic. Well, thank you for that, Tommy. Hopefully that's shed a lot of light, probably raised a few more questions once people have a chance to think about it, but at least it's answered, I think, pretty much all of the immediate questions, which is incredibly helpful. So appreciate your time, and better squeeze it in before your sort of childcare duties.
Yes, thank you.
Kick in. So fantastic. Right, I'm going to wrap up. Before I do, just a reminder, anyone that's planning to attend ITF 111, today is the last day, 23:59 UTC. If you want to pay the standard as opposed to the whatever the extra $50 fee to attend if you do it after today. So if you're not registered and want to go, save $50 and register before midnight. And save the money. Although of course fee waivers are also available still. So with that in mind, thank you everyone for your time. I hope you found that useful. I will put the recording online as quickly as I can, so probably later on today, because I suspect you might want to go back over it and sort of listen again to the questions. But thank you all for your time. Thank you in particular, Tommy, for your time, and we'll catch up again same time next week. So have a great week, everyone.
Andrew, cheers.
Cheers. Thank you.
Thank you very